I'm going to go over hooking up the NHD-3.12-25664 OLED display to the Arduino Mega 2560 board using DcsBios, and got a video here just showing basically you can see the output from DcsBios. We got the DCS A10 running in the background. You see me switching through the different jammer modes. And I just threw that up here just to show you that there's data is being exchanged, being sent from DCS to the display, and so basically I'm hoping eventually they'll come out with an F16 for DCS, and then this display would be perfect for a DED solution. And if they ever did that, and then DcsBios would have strings coming in each line of the DED display, and then you just pipe it into your Arduino code, and that would be sweet. Anyways, I'm going to go over wiring up the NHD display. You go to the data sheet, and we're going to be running it in a 4-wire SPI mode, a serial SPI mode, not parallel. There's a lot less wires with the serial interface as opposed to the parallel interface. And you can see on the display has 22 pins to interface the display with the Arduino board. But most of the most of these pins are going to be grounded, and we're only going to be using a few of the actual pins to transmit data. And so here we have the serial interface, and your pins 1 through 22, and pin number 1 is going to be is a ground. Pin number 2 is your supply voltage, so you can wire that to your 5 volts on your Arduino board. Pin 3 is no connection, so you just leave it unconnected. Pin 4 is your data command pin, so this is going to tell the display, the chip on the display, which is an NHD-3.12. This command will tell the display whether the next incoming information is going to be a command or an actual piece of data, a byte of data. And you can see it'll be 0 if it's a command, so the pin will be low if you're sending a command to the display, and it'll be high if you're sending data. But the also forgot to mention, I'm using the U8. Forgot the name of it. I'm using the U8G2 Library, which is does all the work for you. Makes it so simple. Trying to write the driver for this display by yourself, I'm in the middle of it, and it's a real pain in the ass. But just because I'm a beginner. But with this library, all the hard work's done for you, and it makes it so much easier to set up this display. And so anyways, where was I? I was on the data command, this pin, and on the Arduino, I have it in my code. I have the data command pin set to 42. You can set it to any general purpose input output pin that you want. Just remember where you have it hooked up to, because it's going to be used in the down here, which I'll get to in a minute, when you're instantiating the object. You're going to need to have the data command pin. You have to have it as part of one of the parameters for the object to set up. Basically, I guess, the constructor for the C++ object. You'll need the data command pin, the reset pin, the chip select, and the MOSI and source clock, and we'll get to that in a minute. Anyways, back to the wiring diagram, or the wiring of the display. So I left, it was off here, the data command pin number 4, and then pins 5 through 6 are grounded. We don't have to worry about those. We just hook them all together and hook them to a ground. And then pin number 7 is going to be your source clock. And on the Arduino, I have the where is it? Source clock here, pin 52. So that's the source clock pin on the Mega board. Let's see, source clock. Okay, now next, so that's pin 7, source clock. Next, pin 8 is your serial data input signal. So that's your MOSI, because your Arduino's acting as a master, so it's going to be outputting the data to your OLED display, which is going to be getting the input. It's going to be receiving the data from your Arduino. So this is your MOSI pin, and your MOSI gets hooked up to pin 8 on the display, and then in the Arduino, the MOSI is pin 51. We won't be using the MISO because you don't read anything from this display using this library. It's just input. I usually set the MISO. I don't hook the MISO up, but I do set it as an output. I think because if you put it as an input, it may take that. It may drive your chip, your Arduino, into slave mode and start wanting to receive data instead of sending it. But I'm not sure about that. But anyways, the way I have it set up, I don't have MISO connected. I have it set as an output. And okay, back to that was mostly pin 8, serial data input. Pin 9, there's no connection, so I don't have it connected. Pins 10 through 14 are all grounded, and pin 15 is your reset pin. So, like I said, when you instantiate the object, over here is one of the parameters is the reset pin, and I have my reset set to pin 44. It's just gonna be any general purpose input output pin that you choose, and the U8 library will do the reset for you. It does everything basically, initializing the display for you. So it does the reset of it drops this pin low and then high to reset the SSD chip that's controlling the OLED display. It does all that for you. All right, so that was the reset is pin 15, then pin 16 is your chip select. So if you're using multiple peripherals, like you have a display and then you have some other peripheral, whatever you're using, another display, say another OLED display, you'll make the one display active and the other one non-active using using the chip select. But I'm only driving one display, one OLED display hooked up to the Arduino board, so I just ground this pin permanently. I just leave it grounded. So that your display is always active. That's the pin that's the peripheral that you always want active, because there is only one. And then BS1 and BS0, these right here, these need, because we're running 4-wire serial interface, these both need to be low. So I grounded these as well. I just grounded both BS1 and BS0 to put them to ground permanently. Because that's all I'm using as a 4-wire serial interface. And okay, and then the rest, these last 4 pins, this is this MF source clock, and these have to do with the built-in fonts that are built into the Newhaven Newhaven display. But I'm not using those, and I don't even know how to use those. I wish someone had a video on that. But anyways, I left these 4 pins unconnected. I didn't even bother connecting them up, and it seems to work fine with those not connected. And I'll be using the fonts from the U8 library. I'll show you how to do those in a minute. Okay, so that's basically all the pins wired up, how I have them wired up. to drive this display. All right, so now I'll go over the Arduino code. You need to include the U8G2 library and the U8 library. I think it's the older version. The G2 is a newer version. I used the to include statements. For that library, you can go to GitHub and download the library and just install it into the Arduino. This is the page with all the reference of the methods or the functions that the library has. You can see like a begin function here. You click on that, and this function simplifies the setup procedure for the display for the Arduino environment. Basically, let me see. I think it does, like I said, it does. It'll do the reset. It'll reset the display for you. Configure and clear the display and power up the display so it's all ready to receive data. You'll see it in the code here in a minute. But like I said, this library simplifies everything for you. You don't have to mess around a lot with initiating the display yourself, because the library does it for you. And include your SPI header and of course your DcsBios and your Arduino H header. Here I've got a master caution, that sets off the LED, and a lot of times I use that for testing, just to see if I'm having problems and the display's not working. I'll have a simple LED hooked up, to this master caution, and if that works, then I know that DCS is sending the data through. It helps eliminate a lot of other causes that might be going on. It helps in troubleshooting. I always try to stick an LED on my boards to simplify troubleshooting, just for basic, even for knowing that my program's being flashed into the firmware. It always helps just to have put a little loop code in there, like a heartbeat or whatever, so that you know that you're actually flashing your programming into your Arduino. It's actually making it there. And like I said, a step further up would be using the simple master caution. To know that actually the data is being received from DCS too as well. And then I have my the MOSI and the source clock are 51 and 52 on the on this Arduino board, and then like I already went over my chip select and my data command pin and reset pin. And then down here is where you're going to instantiate the structure, or the object for your display. So you need to go back to the GitHub to your reference here, and your reference here for the U8 library, and trying to remember, I think it was under here, Arduino setup. Yeah, you go into there, and then you got to look for the display chip that drives your display. And like I mentioned before, for this display, it's the NHD-3.12, and I'm also running out of time here, so maybe cutting this off and then pick it up on part 2. But mine was down here, SSD1322 NHD 256 by 64 pixels there. This is the one you use, and then it'll give you a list of the different types of memory usage that you want to use for the display. I think I chose the F for the full frame buffer. This is what the F means here. You see these little numbers in this part of the structure of the object. You can see that most of the numbers stay the same, except here where you have a 1 or a 2 or an F, and they give you the different types of sizes of page buffers. And I'm out of time here, so I'll pick it up in part 2.